Of course, in lab 6 we use PEID and PEView. So PEID is also used to check packed files, and PEView is also used to check packed files. So these are two tools that we have used so far. Okay, so basically I will go to the section where we use uh, the labs actually. So for PEID, if you import a file, exe or DLL file, and it comes into the tool, you will see it this way. Okay, and there you can check from either the entry point, this is the entry point, or from the bottom section where you will see what is being packed in the file. Okay, so in this example you can see that basically it's a compiler information C++ DLL file, that is information that's been packed inside this file, and it contains a text information, yeah, as the entry point. So you can see from here. Okay, yeah, so from here you can see this is the packed information. It shows that it's a compiler information that is there. So this is a typical example. Okay, typical example for PEID. So I'll go to the PEView section because today's class will be on PEView. So basically, if you import the on PEView, if you import a file and it comes into, let me quickly, yeah, so this is the PEView section. If you open the PEView, this is the stuff you're going to see. So you can import either a DLL file or exe file. Yeah, if you import it, it will execute and you will see some stuffs like this. Okay, so you go to the signature section, you can see the signature, and if you go to the header section, you can see the date when this file was compiled. Basically that's the timestamp of this. Okay, and if you check other section like the text and the location, that's when where you're going to see the virtual size and the size of the raw data. So these are the two things we will discuss more about. Okay, yep, so we've seen this before. So if you check on lab 7, for lab 7 this is unpacking. Okay, I will discuss this more later, but Abdullah already explained to you. If you discover that information is being packed in a file, how do you unpack it? How do you remove it? Okay, so this is the section that we do in lab 7. Okay, so I will quickly go to the PEView file. Let's say this is, okay, this UPX PEView. Yeah, so this is the PEView. So you can see this is a tool, PEView. Once you open it and it opens this way, you will see that these are the files, DLL files. Okay, so let's say file number 2. Okay, so you import it. Okay, here you can see information about the signature. Okay, and other information related to this. You can see the raw data information. Okay, and you can detect if anything is being hidden, and you can see the virtual size and the raw data size. So these are the two things that we are interested in today: virtual size and raw data size. Okay, so the virtual size of this is normally written in hexadecimal. Okay, the virtual size of this file is 00017,000, and the raw data size is basically 0 altogether. Okay, so you have to compare the size of the virtual size and the file, the raw data file. So that's what we are going to do in this chapter. So I'll go back to the slides. Okay, at least we've seen how the tool looks like. Okay, so in PE files, we have two sections. Okay, two sections has two key size parameters: the virtual size, what I just show you now, the virtual size, okay, and the size of raw data. So these are the two parameters that we are interested in. But then what is a virtual size? A virtual size is actually the size of the section when loaded into the memory. Okay, so for example, you have the memory. Okay, so once you load the file into the memory, the section, this is the section. The size of it is called the virtual size. Okay, so this is virtual size, VS. How about raw data files? Raw data, the size of raw data is the actual size of the section stored on disk. Okay, so for example, the raw data should be the size, the actual size of the data when it is loaded into the memory. So basically, it's the size, it should be approximately almost the same with the virtual size. Okay, so for example, this is the virtual size and this is the raw data size. So they should be almost the same actually. Okay, raw data. So that's the meaning actually. Okay, and let's say outside is the memory. So based on this, we can understand that the virtual size, if the virtual size, these are rules that we need to remember, okay? If the virtual size significantly larger than the raw size, meaning if the virtual size is greater than, is significantly greater than, okay, the raw size, then this is common in packed or obfuscated information basically. Okay, so that means that it's likely that a malware has been packed in it. Okay, but then if the difference is not much, just a little, let's say you find out the size of the virtual size is 12,000, but the raw data is 12,001, this is not much. So that's why we use the word significantly. Okay, so the difference must be so large. So for example, if you find out that the virtual size is 12,000, but the raw data size is giving you like 20,000. 20,000 and 12,000 is significant. It's too much the difference. Okay, that means something is being packed in it. Okay?
Doctor, sorry for interrupting, but I have a question.
Wa alaikum salam. Yes.
Yes. Doctor, isn't usually the virtual size is larger than the raw data, not the vice versa? Like,
The
for
virtual,
example, the raw data. Yeah.
yeah, it doesn't matter. What is important is the sizes should not be so much. Okay? It shouldn't be so significant. Okay? It can be close because both of them are loaded into a memory section. So that means that both of them, the sizes should be close. Okay, you can have the virtual size to be a little bit more than the raw data. It's okay if the difference is not much. It's okay, and you can have the raw data to be a little bit more than the virtual size, which is still okay. What is important is we don't want the size of one to be so significant more than the other one. Okay, so basically, let me go back here. Okay, so basically, the virtual size should be similar to the size of the raw data. If we have the sizes to be similar, for example, 12,000 and 12,100, this is not much, meaning the difference is not much. Okay, so that means that this is unpacked file. We don't have hidden information in it, nothing so suspicious in it actually. So that's the meaning. So now the difference has to be significant, much larger than the other one. Then we say that this is basically a suspect. Something is being hidden in it, basically. Okay. So it's significant discrepancies. You can see the word significance is consistently used, meaning that we don't want the sizes to be too much. Okay. Significant discrepancies in executable files. Okay. It implies that something is hidden in the text section. Okay. Or and this may indicate code injection, hidden payloads, or self-modifying codes. So if you have discrepancies, especially in the text section, this may indicate that maybe a code injection is being injected in it, or a hidden payload, or self-modifying. So let's quickly go back. Let me quickly go back to the tool. I will show you the text because now I'm talking about text section. Okay, so for example, if you go to the PEID, where is the text section? This is it. Okay, this is it. How do I know this is it? You can see it end with text, and also you have another one here. Okay, but where you can see the virtual size and the raw data is this. Okay, the text. Okay, text section. So this is where you can see the raw size of raw data and the virtual size. So these are the two things that we are interested in today. Okay, so now we understand that if there is significant differences or is significantly larger than one, it means something is hidden in it. Okay, so now we are going to see how we can calculate this. Okay, how do we know it's true? We have to calculate basically. So now it means that this is an example. I extracted this from one of the files. Okay, so if you go to the text section and we check under the virtual, you can see this is what 000A688C. This is what the hexadecimal value. And size of raw data, this is 000A8000. This is what hexadecimal value also. So we are dealing with the virtual size, this one, and the raw data size, this one. So how do we know if it is larger? So we have to convert it to decimal. Okay, decimal means in normal numbers. That's when we will be able to do the comparison. Okay, so you have to extract the virtual size. This is the virtual size 000A68C. Okay, that's the virtual size, and it's in hexadecimal size. And then we have to convert it to normal number, which is decimal number. So basically we identify now the hexadecimal number is this. Okay, that's what we have here. That's the hexadecimal number. Okay, so we need to expand it using position notation. Okay, basically you have to start numbering from here. This is 0, this is 1, this is 2, this is 3, this is 4, but these are zeros, so it's going to give you zeros anyway. So basically 16 is the base system. Okay, so it means that C this one, multiply by 16 raised to the power 0. Then that's for this, the first letter, okay? Then for the second letter, which is 8, so it will be 8 multiplied by 16 raised to the power 1, because it's raised to the power 1 here. That gives us this, then plus the next letter, which is what? 6. 6 multiplied by 16 raised to the power what? 2. Okay? Then the next letter, which is A. A multiplied by 16 raised to the power 3. So we need to evaluate this, okay? Uh, Once we evaluate this one will give us, well, this will give us what? 12. Because C is 12 actually. And 60 raised to the power 0 is 1. Okay? A is 10, B is 11, C is 12. So that's how we got this. This is 12. Okay? So this is how we got this. Then we go to the next one. 16 raised to the power 1 is 16. 16 multiplied by 8 will give us 128. Then we go to the next one. 60 raised to the power 2 multiplied by 6 will give us 36. Sorry. A is what? A is 10 actually. In hexadecimal, A is 10. So 60 raised to the power 3 multiplied by 10 will give us this. So you can use your calculator to add up this, and it will give you 42,000 plus. Okay, so that's the hexadecimal value, 42,636. So this is the virtual size. Then we have to go back to the other section, which is what? The raw data size. So we have the raw data size. The raw data size is 000A800. So that's for this. So this is the raw data, 000A800. That's the size of the raw data. Okay, so basically we also bring it in here. This is the hexadecimal value. Okay, this is our rest power 0, 1, 2, and 3. Okay, so that means that the first one, 0 multiplied by 16 raised to the power 0 is 1. So 0 multiplied by 1 will give you 0. So that's this. Okay, the next one also is 0. If you multiply by 16, it will still give you 0. Okay, so then the next one is what? 8. 8 is 8 times 60 raised to the power 2. Okay, that's 60 raised to the power 2 multiplied by 8 will give you 2048. Then we move to the next one, which is what? A. A is 10, so we have 10 here. Okay, this is 60 raised to the power 3. Okay, multiplied by 10 will give you this. So you need to add up this, and it will give you 43008. So this is the hexadecimal value for the raw data. So now we have to compare if we can have significant differences between the virtual size and the raw data. So basically, the virtual size we calculated is this. The raw data size we calculated is this. Is it a significant difference between 12,636 and, sorry, not 12,000, 42,000, 42,000 and 43,000? Is it a significant difference? The difference, is it much? Well, actually, this is not a significant difference. There is no much difference between 12,632.36 36 and 42,000. Sorry, this is not for 12,000. 42,636 and 43,008. There is no much difference. Okay, so basically there is no significant difference between these two, and this implies that we don't have any packing. So it's an unpacked file. There is nothing in it. No malware is hidden in it, basically. So that's the meaning based on this. I hope you get what I'm trying to explain. If you don't understand any section, feel free to ask. I will show you how to do it. So in case if you are using a scientific calculator, yes, you can use scientific calculator, but it will not show you the steps. Okay, let me discard this. Let's go to calc. This is calculator. Okay, so basically, mostly if you open this, it will be in the standard format. This is the standard format for the calculator, so you need to change it to scientific. This is scientific calculator. Okay, yeah, so this is the scientific, and then you need to look for the hex. This one doesn't have the hex, so I need to look for the one that is having the hex value. Okay, this is for graph. Programmable, yeah, so this one has the hex. So let's look at the value we are looking at. We are looking at this value for the first section for the virtual size. Let me just copy it and go to the calculator. Okay, this is the value. Okay, so you can see that if you convert this value, okay, it will give you this, and the value will be what? 42,636, which is exactly what we have here also. So you can do the conversion from hexadecimal to decimal with a programmable calculator, and it will give you this. If you are converting it to octadecimal, it will be this. If you are converting it to binary, it will be this. But now we need the decimal, okay? From hexadecimal to decimal. So 14,636, exactly what we have here, okay? 14,636. So you can go back to the raw data section also. This is the value for the raw data. I will copy it and go back to my programmable calculator. Let me clear this first, and then I will click on hex. I will paste it. Okay, that is this. Okay, then it will give you 42,008. That is the decimal value. This is the binary value. This is the octadecimal value. Okay, so basically we are dealing with this. 42,000, 43,008. So that's the decimal value. So this is a good way. However, it doesn't show you the steps how you arrive at this value. So for example, if you are dealing with multiple choice question, yes, you can apply the scientific calculator. If you have one, you can simply press it and check, okay? But if you don't have a scientific calculator, you need to follow the steps, okay? If it's a normal standard calculator, you need to follow the steps and then you get the answer. So that's for the first exercise. Let's go to the second exercise. For the second exercise, PEView exercise number 2, I uploaded another file, okay? Upon uploading the file, I go to the text section. Okay, this is the text section. As I told you before, the malwares are mostly hidden in the text section. So if you check the text section, you will see the virtual size and the size of the raw data. In this case, we have FA7 and the raw data is 1000. Okay, so we take the same steps that we took the previous one. So this is the virtual size FA8, FA7. Okay, so F87, the virtual size 0000 FA7. Okay, so this is in the hexadecimal format. So this will be 0, this will be 1, and this will be 2. Okay, so that means that we have 7 multiplied by 16 because hexadecimal is base 16. Okay, raised to power 0. This is 0. Okay, so 16 raised to power 0 is 1. 1 times 7 is 7. So the whole of this is 7. Then we go to the next one. I think there may be some mistakes here. I don't know. Because this is supposed to be raised to power 1, raised to power 2. It shows raised to power 2 here. I think there's a mistake here. It's supposed to be raised to power 1. So A times this. If we say raised to power 2, it will give us this. A is 10 because after 9, the next number is A in hexadecimal. And A is 10 multiplied by 10. Whatever number it's given, you multiply it. Okay. And then the next one. But I think there's some mistake here because this is supposed to be 1 and this is supposed to be 2 actually. Unless if I didn't take it correctly. Here this is 0. This is 1. This is 2. Yeah, I think I made a mistake somewhere. So this is basically supposed to be raised to power 2. Okay, so F is what? F is 15 multiplied by 16 raised to power 2. And whatever it gives you, it will give you, you need to add them together and get the correct value. But then let me use the scientific calculator to be sure that there is no any mistake. Yeah, so if I take this, I need to clean this. The hex value is this, and it gives me 4000,007 as the decimal value. So 4000, let me see, is it the same? Definitely it's not the same because there's a mistake somewhere. Okay, so I need to change this slide and update it a little because this is supposed to be 1, this is supposed to be 2. Okay, so the correct answer is supposed to be 4000 plus here. Okay, 4000 plus is the correct answer. Let me see if I can take it from here. I will update the slide later. There is no issue. Yeah, so this is supposed to be the correct decimal value, 4000 plus. Okay, so I go to the next one, which is the raw data. I hope I didn't make the same mistake here. So the raw data section, we have a raw data of 1000. Okay, so this is 1000. Okay, this is the raw data value. Yeah, so this will be, let me do the slideshow. Yeah, so this will be what? This will be 0, 1, 2, and 3. Okay, so this is 0, 1, 2, and 3. So this is correct. This one is correct. Yep. So basically, 60 raised to power 0 is 1. 1 times 1 times 0 is 0. So this is 0. Okay. Also, this 60 raised to power 1 is 16. 16 times 0 is 0. Then 60 raised to power 2 is 256. Multiplied by 0 will still give you 0. Okay. Then 60 raised to power 3 is 4000 plus times 1. Okay, it will give you 4000. Okay, so basically the correct answer here is 4000. 4096 is the correct answer. So that means that also this section there will be no significant difference. Even though in my slide I said there's a significant difference indicating that it's larger, but after I checked now, I realized that this is supposed to be 4000 plus also. Okay, so if you go back based on what we calculated on the is 4007. So if you compare 4007 and 4097, you will find out that there is no significant difference. So basically, let me take the value that I calculated here. This one. Okay. So this should be the correct value here. Okay, so if you have this 4007 and 4096, it means that there is no much differences between these. It means actually it's an unpacked file. So in case if you get a packed information, of course it's unpacked file, though it contains some compiler information. If you check on PEID, you will see the compiler information in it. Okay, but not really a file that's basically packed with viruses, which is UPX files basically. So if we check on PEID, you will see that the file is compiled. I say it's basically containing the C++ compiler information in it. So let's go to the next exercise, exercise number 3. Okay, so on exercise number 3, we have this. The virtual size is this, and the row size is this. So actually from here, it shows that the row size is 000 all through, while the virtual size is 18000. So basically, if we do this, the virtual size, you can find out that if we calculate this, it will give us 98,307. Okay, 98,307. And if we calculate the row size, it will give us simply 0 because all through is 0. So if you multiply 0 by any number, it's going to give you 0. So basically, after we calculated all this, the answer still give us 0. So 0. So 0, if you compare it with this size, 98,304, it will show that this is a significant difference. Okay, so the difference is significant. So actually, Exercise number two, there is no exercise number one and two, there is no significant difference. But it's in exercise number three that we actually have packed file. Okay, packed file, because there's significance difference basically. So then if you check on the PEID, okay, if you use the PEID, you will see that there is what UPX information packed by somebody called Marcus and Lazarus, the name of the guys, and you can see the UPX information here. Sometimes the UPX information will show also here at the entry point, but in this case it only shows here UPX. So UPX, anytime you see UPX information, is actually a malware information that is being obfuscated or packed into the file. Okay, so what do we do next? Uh, After we find out that there is UPX information in it, the next thing is you would like to unpack it, right? Now that's why it will take you the next exercise, the lab exercise that we did. You use the UPX tool. We share with you the UPX tool and we did the lab exercise. So anytime you see UPX, you have to apply the UPX tool to do the unpacking. Okay, unpacking, you have to do it through the command prompt. So you go to CMD and you have to simply install the UPX tool. UPX tool, you need to install it on the C drive on the Windows on that system 32. That's where you're going to put it. If you put it there, then you come back to command prompt and simply type UPX and it will show you the version that is there. Okay, once it shows you this, you can change the directory to C. After you change the directory to C, then you need to take your file to C drive. That's the file that you want to unpack. So you take it to C drive and then you come back to the command prompt and run the command that we gave you. So basically UPX dash zero dash D dash zero, and then you put the new file's name and the old file's name. So it will unpack it for you and it will put it the unpacked version in the C drive. This exercise you have already done in exercise lab number 7. Okay, so I'll give you another exercise today uh, using PEView. This is the exercise. We have this virtual size and we have this raw data size. Uh, while this I think is a simple exercise because even from the screen you can see the values are the same, right? So since the values are the same, there is no significant difference. It simply means that there is no any packed information in it. So you don't have to go through any long calculation to do this. But we can check other ones. So this is the last slides for today. Okay, so we can check other ones. For example, if I want to check another file based on the UPX files we gave you before. Okay, this is DLL. I need to change it to executable. Okay, so let's say I take the first one. Okay, so I bring it in. Okay, so this is the UPX file. I need to check for packed information. Yeah, so this is the size. Okay, virtual size. Okay, and this is the size of the raw data is 00. Obviously, this is also a packed file. Without going through long calculation, I can see it's a packed file. So I can take this. Okay, let me take this also. Duplicate and put this as number 5. Okay, I'll change this. So you can go through it and calculate the value for this. Okay, though it's shown that clearly if you finish the calculation, the answer you should have is the packed file, because the raw data is 0 and the virtual size is large. So, and the raw data here, size of raw data is all 0 if you check. So the raw data is this and the virtual size is this. So after conversion to decimal, you should have basically you should have what? Packed information in it. So if you have any question, feel free to ask, and I will ask the last question for today, and then we can call it a day.